Good afternoon, once again. Welcome in the room number 7 on the 9th Code Dive conference. We are in Kino Nowe Horyzonty in Wrocław, and our conference is organized in the hybrid mode, so please take your seat. Please mute your phones during the next speech, and have fun. After the speech, there will be time for 2-3 questions on the Q&A session, so please raise your hand, and our volunteer will come to you, give you the microphone, and you will be able to ask the question. Okay, so it's time for our next speaker. Our next speaker, Remigiusz Marciniak. Remi is a software engineer at Nokia. He doesn't have a long professional experience. However, he is a real IT passionate. He holds Master of Science in Big Data Analytics, and he's an engineer, and he do it by studying Medical Informatics. In his free time, if Remi is not working out at the gym or spending time with his friends, he must be learning new things. Among them are economics, business management, and IT. You can stay in touch with Remi on LinkedIn, and he will provide the QR code later. Remi, come to the stage. The stage is yours. Good luck.
Hello, everybody. Can you hear me well? Raise your hands, the last row. OK, thank you. So, hello, everybody. I am really happy that I can be here and present to you. Can we, because it's not visible on the slides? OK. Thank you. So, I'm really happy that I can present to you this interesting topic, which is an insightful analysis of artificial intelligence in telecommunications sector. My name is Remigiusz Marciniak. It's a Polish name, so it's quite complicated, so I will say it once again, Remigiusz Marciniak, but you can call me Remi. A few words about me. Thank you, host, for the really nice welcoming. So, I am a Master of Big Data Analytics and Medical Informatics engineer. In my free time, I like to volunteer. Here on the left picture, we can see me in Śnieżka mountain in Poland. I was cleaning the mountain trails there. And the presentation plan for today is that on the beginning, I will, of course, present the main topics of our presentation. It will take around 45 minutes, and then there will be time for question and answers. And finally, there will be time for lunch break, for which I can't wait. And what are the goals of our presentation? So first of all, I want to show you artificial intelligence use cases in telecommunications. And then I want to show you the impact that they have on our daily world. And I want to inspire you to take actions to change our world. And I have 3 key messages for you of our presentation. So the first one is that AI thrives the development of telecommunications. The second one is that AI applied to telecommunications can change our world. And the last one, and most important one, is that you can change the world. The roadmap for today, for the presentation, is that on the beginning, I will tell you something more about telecommunications and artificial intelligence. And then I will move to use cases of AI in telco. Eventually, there will be time for summary and conclusions and Q&A. And of course, lunch. So to begin with, what is the telecommunications sector? So the telco sector is made up of all telecommunication companies, telephone companies, as well as internet service providers. And the second fact, which is more important in my opinion, is that it plays a crucial role in the evolution of mobile telecommunications and the information society in which we live nowadays. I have found 2 inspiring quotes. This is the first one by the company Deloitte. It states that the telco sector continues to be at the epicenter for growth, innovation, for almost any industry. And the mobile devices and related broadband connectivity continue to be more embedded in our society. And I think that we all can see this, that we need to feel connected to the world, to the internet. So it's really important for us, for the society. And many other services and sectors develops because of the telecommunication, for example, video streaming, IoT, and mobile payments. The second one is by Investopedia, and it states that the telecommunication is the world's biggest machine. And there are devices which are connected together, for example, telephones, mobile phones, and of course complex networks and PCs. And this system touches nearly all of us. And I think that we all know that this allows us to speak, to share thoughts, and to do business globally with nearly anyone on the globe. And of course, telecommunication companies make this happen. I think that you will find those quotes inspiring. So we can illustrate the telecommunications as many devices, as the complex systems with many devices such as antennas, servers, databases, satellites, and so on. And of course, we can't imagine this system without telephones, mobile phones, smartphones, routers, and many other devices. And the fact is that this system generates an enormous amount of data every second. And of course, artificial intelligence can do something really useful with this data. Now I want to tell you something about the history of mobile communication. So in the 80s, we had analog voice, and we weren't able to transmit any more data. Then in the 90s, we had 2G, so second generation, and digital voice, text messages, and slow and expensive internet. Then there were time for 3G and high wireless connection, and it was in 2000s. And then 2010s, the era of 4G and faster networks. And now it's the era of 5G, so 2020s, and the idea that all devices are able to connect to the internet. And talking about the history reminds me of the old times. And the old times are the Nokia phones. And now I want to state something really important, that nowadays in Nokia, we don't produce phones anymore. We create sophisticated IT solutions and networks. And I have a surprise for you, because I have this old Nokia phone with me. You can see it. You can even touch it if you want. It's real, right? And I want to check if it's true. So I will drop this phone. Are you ready?
Yeah, go for it.
Oops. Well, the phone is okay. I mean, the screen is okay, so it works. So do we have any volunteer for the new iPhone? Any volunteer? No? Okay. And of course, I hope that this phone won't vibrate in my pocket. And we can think about the future. So what the future will bring. And the 6G is the future. And the main trends in 6G are UAVs, so unmanned aerial vehicles, satellites, artificial intelligence, of course. And later I will show you why. Energy efficiency, which is really important nowadays, and virtual reality, augmented reality, and new spectrum. And what are the values generated by the sector? So the first one is that this fact that I said, that it satisfies our basic needs. So we can feel connected, we can be in touch with nearly anyone on the globe. It's crucial for security in many ways. For example, many sectors such as healthcare or banking rely on telecommunications, so it's really important to take care of reliability of telecommunication networks, and I have a really interesting use case which I will show later. And of course, it boosts economy, so we can do business with nearly anyone on the globe. And our communication is improved, it's more efficient, it's more flexible, so we can, for example, work from home, we can be flexible. And of course, the collaboration is improved. And there's another funny picture. This bird on the right has Wi-Fi, so wireless connection. And now I want to say something more about the global telecom market and about the growth of it. So we can see that from 2021 to 2022, it's 9% of development. And in 4 years, it will grow by 26% more. So it is a really, really huge number. What are the challenges of the sector? Because there are many of them. The first one is energy efficiency and green energy. So we can see the trends in the nowadays world that green energy is the future, and also energy efficiency. The next thing is the network security. So we can see many threats which are in our daily world in which we live, and of course, they are the threat to the networks. The next thing is generating massive amount of data. So we can see that there are many data generated every second. And we may take advantage of this fact. We may apply some artificial intelligence methods, which I will show you later, and create a really, really good value with this data. And the last thing is that the demand for traditional service is decreasing, so customers want innovation. And I have a question to you. How many of you know artificial intelligence? Raise your hand. Okay, so there is some of you. Nice. And now I want to briefly explain what is artificial intelligence. So it is intelligence which is demonstrated by machines, such as computers, as opposed to the natural intelligence which we, beings such as animals and humans, have. And the second fact, the second term, states that this term, artificial intelligence, is frequently connected with cognitive skills that are associated with our human mind, such as learning, problem solving, the ability to reason, discover meaning, generalize, or learn from past experience. And I think that you know those three terms, which is artificial intelligence, machine learning, and deep learning. And the relation is that the machine learning is a subset of artificial intelligence, which is focused on creating a solution which solves a task without explicitly programming the rules. And deep learning is a subset of machine learning, in which is focused on artificial neural networks. And neural networks are, of course, in beings, in animals, in humans. So it is also inspired by the nature. And there are main four machine learning types, which is supervised learning, where the data is labeled, unsupervised, where the data is untagged, and reinforced, where the main idea is that there is a model which tends to maximize the reward for solving an issue. And the last one is semi-supervised learning, which is a combination of the first one and the second one. So some data is labeled and the rest isn't. So the first task is classification. So briefly speaking, a program must draw a conclusion from observed values and determine to what category an observation belongs to. And I have a funny example here. So the task is to classify the images as dogs or muffins, and of course, how to confuse machine learning. So this is the first example, and I also feel confused because some of the pictures looks the same. The second one is regression. It is also supervised learning. And the main idea is that the program, the code, must estimate and understand the relationships between variables. And this analysis focuses on dependent variable and a series of other changing variables. And I have another example. So this is a chart of reported happiness as a function of income. The thing that we all probably know and think about the happiness and income. So on the x-axis we have income in thousands of dollars, and on the y we have happiness score. So if we don't look at this line, we have data points which are, let's say, we have a mess there. And if we apply regression, for example, linear regression, then we can have a line, and we can predict or even estimate the value. So, for example, let me assume that we don't have the happiness score for $50,000, and then we can look at the line and we can see the happiness score, which is of course predicted. The next is unsupervised learning and dimension reduction. So Briefly speaking, it reduces the number of variables which are being considered to find the exact information required. So we can imagine that we have a table, which is our data set, and we have columns, which are features, and for example, we have 10 of them. And we want to reduce them, and we can, of course, do it. And here is the example. So we have, for example, three dimensions, 1,000 points, and we can go to 2 dimensions with 100 points, and then to 1 dimension with 10 points. But the most approach is that, for example, we reduce from 10 or maybe 5 to 2 dimensions. And another technique, which is slightly connected with this previous one, because it's often used for clustering, is clustering. So it involves grouping sets of similar data, which is based on defined criteria. And it's useful for segmenting data into several groups and performing analysis to find patterns. So here I have the example. There are two dimensions, and we can see that there are the groups. There are the cities in the United States, and they are grouped. And here I think that there were applied the k-means algorithm, and we can see that without any expert knowledge, the groups were created. And here I have a brief comparison between machine learning and deep learning. So in machine learning, the engineer extracts the feature, and in deep learning, it's done by the network. So this is the main difference. So now I want to present you use cases of artificial intelligence in telecommunication sector. So the first one is transitioning from rule-based systems to machine learning-based systems. So on the left, we can see that there is a system which is rule-based. So we have rules which are created manually by the engineers. And on the right, we have transitioned to the artificial intelligence, to the machine learning-based system, in which the rules are encapsulated in the model. And the facts are that the manually created rules do not scale to capture complexity of today's and future's networks. And the second fact is that AI models provide insights into correlation and causation. And the last fact is that AI can capture the behavior of the network, which is only apparent after processing large amounts of data and, of course, complex data. As I said on the beginning, we can only imagine how many data is generated by the telecommunication sector. And we can, of course, gather this data into a data lake, and then we can apply anomaly recognition. So we can detect anomalies, which is really important for network reliability. And of course, if you have many data, then we can represent the data, for example, as a graph. And then we can see, for example, if the network is overloaded, if there are some problems with the network, or if the network is functioning normally. So in general, anomaly detection helps us to detect issues and retrieve their root causes, and of course monitor them in graphical user interface. We can annotate newly discovered network issues using the domain expertise that we have, and also insights from AI models, from the complex and enormous data. And of course, we can continuously adapt and add the new issues and fix them. And in general, about the network performance monitoring, so we can apply unsupervised machine learning where no expert knowledge is needed, because it is done by the model, by the algorithm. Of course, we can identify anomalies, which is important, and I will show you in a moment why. Multivariate relationships can be understood, and proactivity, so detecting anomalies before they escalate to severe problems. And now I want to show you a really important example. So in Canada, there was an outage of the company called Rogers Communications, and it lasted for around 1 day. and around 25% of Canada lost internet connectivity, so over 12 million subscribers. And unfortunately, most of cellular services were affected, including 911. And here is the gap, and we can see that it looks scary. And what was the impact of it? Why it's important to detect anomalies and to act and to react? So it affected governmental services such as Service Canada, Canada Revenue Agency, and of course passport offices. And the more important fact is that medical appointments were rescheduled for oncology patients. So we can see how it is important to monitor the network. And of course, debit cards weren't accepted, so many stores, many companies lost money. It was estimated from few hundred to several thousand of dollars. So we can see how it is important to monitor the network, and of course, artificial intelligence can help. And I have another question to you. Do you know this guy? Raise your hands if you know Buzz Lightyear. I really like this animation. Toy Story is really nice, and I show you this really nice guy because now we'll move to some extraterrestrial topics, to some space-related topics, namely to the artificial intelligence for satellite communication. So the first fact is that satellite communication offers us the prospect of service continuity over uncovered and also undercovered areas, also service scalability. And the second fact is that artificial intelligence is growing as a research field, and of course it has many applications for satellite communication, which I will show you in a moment. But firstly, what are the challenges of satellite communication? So first of all, resource management. They are expensive. Network control, network security. We need to care about some anti-jamming techniques in order to let the network be reliable. Spectrum management, and of course, energy usage, which is, as we all know, important. And there are many use cases of AI for satellite communications, but I will show you some of them. For example, beam hopping, anti-jamming, space air-ground integration, interference management, and ionospheric scintillation detection. The first one is beam hopping. So we have a mismatch between requested and offered resources, and to cope with this problem, we can apply beam hopping techniques. And there is an example of this architecture. So we have this resource manager, the telemetry tracking and command center, and then we can send to the satellite the beam hopping illumination pattern, and we can then provide the service which is, of course, fitted to the requests. And of course, AI can help us with that. So we can model this problem as a Markov decision process to optimize the transmission delay and the system throughput. And of course, we can use deep reinforced learning to solve this beam hopping illumination design. And the fact is that this proposed model can reduce the transmission delay up to 52%, which is a lot, and increase the system throughput by up to 11%. Another technique is space-based anti-jamming routing. So we can see here that we can do the routing, which is anti-jamming, which works in the anti-jamming way. And AI can be applied to help it. And in general, as I said, reliability and security is important as well in satellite telecommunication. And jamming attacks can be, they are a really, really high threat because they can even paralyze the throughput of the network. And AI algorithms are double-edged sword here because they can help, and they can also perform intelligent attacks. And for example, long short-term memory networks are used to learn the temporal signal, and then the results are that the synchronization time is reduced, so it's good. And another use case is space air-ground integration. So we have the ground infrastructure, which is connected with the air, so with the UAVs, balloons, and other vehicles. And then we have satellites in orbits. So this is the space air-ground network. And we can use convolutional neural networks for the routing problem to optimize the performance of the network using traffic patterns. We can also use deep reinforced learning to the source satellite UAV association and the location of UAVs. And the fact is that those methods achieve up to almost 6 times higher average data rate than a direct communication baseline in the absence of UAVs and satellites. Another use case is managing interference. So here we have 2 techniques, which are antenna adjustment and satellite selection. And there are many techniques to minimize the interference. Some of them are SVM, so super vector machines, unsupervised learning, which was mentioned many times in this presentation, deep reinforced learning. And the second thing is that we can do automatic real-time interference detection by using LSTM. So we can gather the data, the historical data, which is free of anomalies, and then we can compare it with the received signal and with the design metric to find anomalies. And the last one, I think, is ionospheric scintillation detection. So in the ionosphere, we have free electrons which can distort our signal, and we want to mitigate this problem. And we can use SVM algorithm to detect amplitude and phase scintillation. And there are 2 use cases which uses decision trees. The first one uses decision trees and random forest to detect ionospheric scintillation events, and the accuracy is almost 100%. So it's like the level of human-driven annotation. So it's a really, really, really great. And the last one is the second use case also has 96 of accuracy, which is much. And another question to you. So how many of you care about the natural environment? There is a lot of you. And I'm asking because now I have the BTS power saving algorithm, and it will be about energy efficiency and energy saving. So in Palestine, in Gaza Strip, there's a district which is called Gaza Strip, and there is energy deficit, and it affects all industries. So there is a need to optimize and reduce the power consumption of the network. Yes. Okay, so I see some problems, but it's okay. Yes. And the model helps GSM radio frequency engineers to choose the optimal value of parameter for BTS saving algorithm, which aims to switch off unused frequency channels. And this model uses K-means algorithm, which is based on unsupervised machine learning technique, clustering. So it looks like this, that we have 3 dimensions, and we can cluster the GSM cells. And we see here 3 clusters, and by doing this this approach, we can on the left we can see that we have a constant value of this parameter, and by using this clustering technique, we can fit this to the real traffic. And the results are that the power consumption has been reduced by almost 21% by the proposed model, which is really, really much. And the second thing is that this model has been deployed and tested on a real GSM network, which is amazing because we can see that this works. And there are many other use cases, for example, traffic forecasting, server occupation, virtual topology design, path computation, and intruder detection. So we are coming to the end of the presentation, and I want to do the summary and conclusions. So there are many places where AI can be applied. AI will have a great impact on the next generation wireless networks, 6G, for example. And this sector generates enormous amounts of data which can be used in artificial intelligence. Power consumption optimization can reduce the network running costs, so the energy efficiency. And another fact is that telecommunication sector is crucial for many other industries, such as healthcare and banking. And lastly, reliability, security, high availability, and proactivity can be obtained by the application of AI. And of course, maybe I can use this Nokia as a hammer, because as we can see, it's really reliable and strong. And now I want to once again say the key messages of our presentation. The first one is that AI thrives the development of telecommunications. The second one is that AI applied to telecommunication can change our daily world. And the last one is that you can change the world. Thank you very much for your attention. Feel free to add me on LinkedIn. Thank you very much.
Thank you, Remi. So now it's time for your questions. Please raise your hand if you have any questions to Remi. Okay, Remi, I guess there are no questions. So
Time for lunch.
thank you once again.
Thank you very much.
Thank you.